In this section, we're taking a look at triangles once again, but this time they might not be limited to quadrant 1. And you can see I filled out some of this information already before, so here are the key details. Whatever that point is that they provide us, here they're using x comma y, that will create the termination side of this angle in standard position, and that termination side of the angle is now the hypotenuse of our right triangle. So that gives us the r, the radius. If we were to spin that point around, that would be the circle with that size radius. So of course we have two sides to that triangle. Make sure when you are creating the triangle, you draw a vertical line from the point to the x-axis, meaning you're going back to the x-axis. The right angle has to sit on the x-axis. So you don't want to draw it to the y-axis. You don't want the right angle here. It won't work out right in all instances. So these are the same ratios we've seen before, right? The sine ratio is the opposite over the hypotenuse. So notice our angle of rotation is on the outside of the triangle. Wait, where's our reference angle? Well, we're using this one on the inside. Let's call that theta prime. Okay, we'll actually talk more about that in our next lesson. Here we're just saying we're using theta instead of the theta prime because it's still the triangle that's formed with that angle of rotation. So it's opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, x over r. And then the tangent ratio is opposite over adjacent, y over x, right? So we're using this theta prime as our reference angle, which means this is our adjacent leg, right? Here's our opposite leg, and there's our hypotenuse. So all of this is pretty standard. We've seen the ratios before. We've dealt with right triangles before. The only difference now is because we're in other quadrants, we may have sides of the triangle that could be negative depending on what quadrant we're in. So that's this note you see here. We'll have to adjust the signs to positive or negative depending on that quadrant. So if you think about the transition of triangles that we've been working with, we started originally with triangles in the unit circle, which meant the hypotenuse was always a radius of 1. Then we transitioned to triangles of any size circle, meaning the radius could be bigger or smaller than 1. But we always drew them with positive side lengths, as if we were placing the triangle in quadrant 1. Now we're going one step farther and saying our triangles can be anywhere. So let's take a look at example 1. They are giving us this point of negative 2, 9. That will be the point on the terminal side of the angle. And then we'll determine the 6 trig functions. So let's draw a little bit of a sketch here. Here's our Cartesian coordinate plane. I guess with a y-coordinate of 9, we have a quite tall vertical axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, way up there. All right, so here is our point. So this is the terminating side of the angle that's drawn in standard position, right? So there's our angle of rotation. But the triangle isn't over here. This termination side is going to be the hypotenuse of our triangle. So again, from here, we want to draw a vertical side back to the x-axis. That's where the right angle sits on the x-axis. So you have a height of 9. The y-coordinate is the height. And the base is the x-coordinate. It's a base of length 2, but because we're in quadrant 2, it's not a positive 2, it's a negative 2. So now we have to find what the radius is, what the hypotenuse is. So this is our Pythagorean Theorem. Which will turn out to be root 85. Again, always check to see if you can reduce radicals. This one does not. So we have a root 85. Now that we've got all three sides, this angle here inside the triangle, this is the actual reference angle. We're calling it theta prime just to make it a different size than the original theta. But that just helps us to label the sides. So this is our adjacent leg. Here's the opposite leg. And of course, here's the hypotenuse. So sine is opposite over hypotenuse. So 9 over root 85. Remember to rationalize your denominator. So 9 root 85 over 85. Cosine is adjacent over hypotenuse. So now we bring in the negative, right? It's a negative 2. Rationalize your denominator again. So negative 2 root 85 over 85. Tangent is opposite over adjacent, and if you write that down literally, it looks like 9 divided by negative 2. But it's just a formatting issue. We don't like to put negatives in the denominator, so we can either put the negative in front of the fraction, or we can put that negative in the numerator like this. So these are the ways we format our fractions with negative values. We call this the rule of negative, but we just choose not to put it in the denominator. Let's take the reciprocals of each of these. So the reciprocal of sine is cosecant. So again, don't take this fraction and flip it upside down because you'll have to rationalize all over again. Go back to the original ratio, reciprocate that, and you get the root 85 on top and the 9 on the bottom. Again, take this fraction and flip it upside down. We'll have the root 85 on top. I don't want the negative on the bottom with the 2, so I'm going to reposition that negative up here. And then negative 2 over 9 for cotangent. So you can see a lot of that work is what we've done before. Pythagorean Theorem, ratios of sides. We just have this extra step of thinking, where is the negative going to be if we're in other quadrants? All right, so we'll come back to this in a moment. What we're doing is looking at patterns in our quadrants. Where would we find positive and negative values? Well, if you think of coordinate points, you know that in quadrant 1, here's some random point, you have a positive x and a positive y. Remember, we said that the sine is paired up with the y. It's associated with the y. So if y is positive, sine is positive. If x is positive, cosine is positive. We know tangent is y over x. It's sine over cosine. So positive divided by positive gives you a positive result. Here, if you have some point in quadrant 2, you have a negative x coordinate and a positive y. So notice sine is still positive, and now your cosine is negative. Here in quadrant 3, you end up with negative x and negative y. So both sine and cosine are negative. But again, tangent is sine divided by cosine, or y divided by x, and they're both negative. So that's why we have a positive result on tangent. And then here in quadrant 4, positive x and a negative y. So we have a positive cosine and negative sine. So another way to memorize this is to use this phrase that you see here, the all students take calculus. The all is referring to what's positive. Everything is positive in quadrant 1. What's positive in quadrant 2? Sine. So the S stands for sine. What's positive in quadrant 3? Tangent. So the T stands for tangent. And what's positive in quadrant 4? Cosine. So C stands for cosine. So all students take calculus. As you rotate in that direction is another way to memorize that. In these little starbursts, you see here it says, referring to quadrant 2, only terms that involve sine are positive. Well, remember, we have to think about both this and its reciprocal. So if you were to take the reciprocal of sine, that would be cosecant. That will also be positive. Okay? Cosine is negative, so its reciprocal is negative. That is secant is negative, and cotangent is negative. Okay? Here in quadrant 3, if tangent is the only item that's positive, well then its reciprocal is also positive, right? Cotangent will be positive. And in quadrant 4, only terms that involve cosine are positive. Well, the reciprocal of that is secant. So secant is also positive. So consider those reciprocals as well as the original trig functions. So let's use that to help us answer these little puzzle problems. State the quadrant in which the angle lies. Here's part A. You can see they're giving us two trig functions, but just look at the first one for now. Sine theta is greater than 1. Greater than 1 means is positive. So where is sine positive? Well, we can kind of look up here. We know that sine is positive in either quadrant 1 or quadrant 2. So we would have two answers, except we have to consider this piece as well. This is the constraint. It's the limiting factor. It helps us to narrow down which quadrant we're in. Cosine is greater than 0. That means cosine is positive. So where is cosine positive? Quadrant 1 and quadrant 4. And then you look to see where do these overlap. Where are they both positive? They're both positive in quadrant 1. So that's our answer. That's where we would find these to both be true. All right, so here's part B. All right, so where is secant greater than 0? Meaning where is secant positive? Well, I don't have secant on my list. Well, we do right here next to that bubble. But remember, that is 1 over cosine theta. So this fraction must be greater than 0. So we can think of cosine having to be positive. So where do we see that? We see that in quadrant 1 and quadrant 4. So then we bring in the constraint. Where is cotangent greater than 0? Where's cotangent positive? So cotangent and its reciprocal tangent are positive. So tangent is positive in quadrant 1 and 3. Right. And then we look to see where do they overlap. Once again, we have this pattern of they are both true in quadrant 1. All right, here's another variation on that. Here's the first piece of information. Where is tangent positive? Okay, so we just saw that earlier. That's quadrant 1 and quadrant 3. So now we bring in the constraint. Where is cosecant less than 0? So now cosecant is negative. Cosecant is the reciprocal of sine. So think of it this way. 1 over sine theta. This has to be negative. All right. Well, if my fraction has to be negative, let's think about the numerator and the denominator. You can see the numerator is already a 1. That implies it's a positive 1. Therefore, the denominator must be negative in order to make the whole fraction less than 0. So that tells me my sign is negative. So where would I find a negative sign? All right, well, that would be either quadrant 3 or 4. So we look to see where they are both overlapping, and the result is quadrant 3. They're both true. So we're going to be bringing these two problems together. We're kind of mashing them together in a way. So in example 1, we had a specific point that told us what quadrant we were in. In example 2, we had more like a pair of clues to figure out what quadrant we were in. If we were to kind of combine these two methods, it might look like what you see on the next page for example 3. All right, so take a look at this. Notice that they don't give us a coordinate point. They give us a pair of trig functions to identify what quadrant we're in. And they want us to find the values of all 6 trig functions, which means we need a right triangle so that we can identify the ratio of sides on that triangle. So where does our triangle belong? So let's look at our clues. Cosecant is 4. We know cosecant is the reciprocal of sine, so 1 over sine equals 4, right? So we just did a substitution. This is our reciprocal identity. Now, instead of 1 over sine, I would like normal sine. So normal sine. So we're going to reciprocate both sides. So it's sine theta over 1 equals 1 over 4. And I like that because it might be easier for you to see, hey, there's our two numbers. There's the ratio of sides. We know sine is opposite over hypotenuse. All right, so we're making some progress. We know 2 sides on our triangle. But also observe that sine is positive. It's not a negative 1/4, it's a positive 1/4. So what quadrants are we in when my sine is positive? That could be either quadrant 1 or quadrant 2. So now we have to bring in the constraint. Where is cotangent less than 0? So cotangent is the same as 1 over tangent. In other words, we want our tangent to be less than 0. We want tangent to be negative. So where is tangent negative? Tangent is negative in either quadrant 2 or 4. So you're looking to see where these overlap. Quadrant 2 it is. We're going to draw a triangle in quadrant 2. All right, so there's your vertical side so that your right angle sits on the x-axis. There's the acute angle. So this is the adjacent side, opposite side, hypotenuse. And our sine ratio is 1 over 4. That's opposite over hypotenuse. So the opposite side is length 1, hypotenuse is 4. we need to find the length of the adjacent side. So Pythagorean Theorem to do the work for us here. So that'll be a root 15. It's a root 15, but it's actually a negative root 15 because we're in quadrant 2. So here we go. Sine is, we already saw that, 1 over 4. So its reciprocal of cosecant is 4, right? That was the given information. Cosine theta is adjacent over hypotenuse, so negative root 15 over 4. Its reciprocal is secant theta. We're going to flip it and then rationalize the denominator. So we're doing 2 steps at once. So there's my negative sign. Here's my fraction. So 4 root 15 over 15. Tangent, opposite over adjacent. That'll be 1 over negative root 15. Right? We have to rationalize the denominator. So putting the negative in the numerator as well. So negative root 15 over 15. And then cotangent is negative root 15. Right, so the puzzle is always figuring out where that triangle goes. You can see in part B, tangent is undefined. Wait a minute, that seems really weird. How are we supposed to figure out where we're at if we don't even have a number to help us out? Is that positive or negative? Well, it's really neither. It's a special case because what we're really doing is we're looking at quadrant angles. So let's talk about quadrant angles in example 4, and then we'll come back up and finish off with part B. So quadrant angles are the angles between the quadrants. We've seen this before, and it makes the most sense to use the unit circle here because here we have a radius of 1, which helps us to identify what these coordinate points are, right? So on the right-hand side, this is 1, 0. Left-hand side is negative 1, 0. Top is 0, 1, and at the bottom, 0, negative 1. Let's think about those quadrant angles in radians. So on the right, this is 0 pi radians. At the top, pi over 2. On the left, pi radians, and at the bottom, 3/2 pi. So let's evaluate this first one, cosecant of pi. We're not using a calculator here, we're just using our unit circle. Cosecant is the reciprocal of sine. So this is the same as 1 over sine at that same angle. It's still pi. So there's pi. Sine is associated with the y-coordinate. So the y-coordinate is 0 at pi radians. So sine of pi is 0. But 1 divided by 0 is undefined. So that's where we might get an undefined situation when we're dividing by 0. And zeros happen on those quadrant angles. Tangent of 3/2 pi, there's 3/2 pi. Tangent we know is sine over cosine, which is y-coordinate over x-coordinate. And so in this case, y-coordinate of negative 1, x-coordinate of 0. Again, we have undefined as a result. The third in the series, here we have secant of pi. So there's pi again. We know secant is 1 over cosine at that same angle. So at pi, cosine is negative 1. So the denominator is negative 1, and that simplifies to negative 1. All right, so the point is we might get an undefined ratio when we're dividing by 0. So if you back up to example 3, part B, where it says tangent of theta is undefined, that means we're dividing by 0. So let's think about what's happening here. Tangent of theta, I don't know where I'm at on the unit circle, but I have the situation where tangent is y over x, and if I'm getting an undefined result, I have to be dividing by 0. So I don't know what the y is, so I'm just leaving that as a y, because at this point, there's 2 possibilities. We're either at the top of the circle, which is 0, 1, or we're at the bottom of the circle, which is 0, negative 1. So the first piece of information, tangent is undefined, provides us 2 possibilities. So that's why we then have to look at the constraint. This helps us to narrow down the options. Our cosecant has to be negative. The only place I see a negative sign is down here at the bottom of my unit circle. So that's the one we want to use. That's what the cosecant is helping me figure out. Now that we know we're using this point, we're ready for the 6 trig functions. Sine of theta, again we said sine is associated with y, so the y-coordinate is a negative 1. Its reciprocal of cosecant theta, then the reciprocal of negative 1 is still negative 1. Cosine theta, that's the x-coordinate. Its reciprocal is secant, right? And when you reciprocate this, right, think of it as 0 over 1. You flip that upside down, you get 1 over 0. That's why we end up with the undefined. Tangent, that's what they told us. Tangent is undefined. So when you take that fraction and flip it upside down, you have 0 on the top. So cotangent theta is 0 divided by -1, so that's a 0.